people, so I take notes when I read. Number of people in a city who have become ill with influenza T weeks after it's in, okay, T in weeks, time in weeks. Very good. And how many people became ill when the flu, when the epidemic began? Part A. Part B, how many people were ill at the end of the 6th week? So what am I asked to find in part A? How many were, or how many got ill when the epidemic began? What do I have to write?
Is that 2449?
2499. Sorry.
No, you're good.
So you're replacing T with 0.
Excellent. So I have to find f of 0. What about part B? How many people were ill at the end of the 6th week?
So F of 6.
Excellent.
And is it 0 because it's the beginning?
Original. Everyone for original initial, everyone is age is 0. Initially, originally. Okay. And part C, what is the limiting size of the population? When we say what is the limiting size of the population, we are really asking as to what happens to F, let's say at 100 weeks, 1,000 weeks, and so on and so forth. Okay? So let's put this function in the graphing calculator. So in y equals, be very careful how you put it in. The top can stay without parentheses in y equals. The top can stay without parentheses because it's just one number. But do not make the mistake of not putting parentheses around the denominator. So 1 plus 2499e. Please put parentheses for the power, which is negative 0.92x, which is t in our problem, but we have to use x in the calculator. So after you enter the function, let's punch in 0 and then 6, and then limiting size, just increase the number of weeks as much as you want. That's the limiting size. You see what happens. We do not round up people. So if I have 7.1 people, I have 7 people. If I have 7.7 people, I still have 7 people. So I plug in 0, and then 6, and then 100 weeks, and then 200 weeks, or 2,000 weeks, and you tell me what is the limiting size of the population. How many people were ill initially? 200 people. How many got sick or were sick by the end of the 6th week? 45,411 people.
Thank you.
And then as the time goes by, in other words, the number of weeks increases and increases and increases, what do I get? Yes, that's the limiting size. As time goes by, in other words, we're assuming here, we are making an assumption, and the assumption is that obviously the town does not have more than 500,000 people, and we don't have visitors. We don't have people coming in, so then the number of 500,000 is increasing. So how many people can get sick? Not more than what the town has, the number of people living in the town, and that's 500,000. Very good. Anything else? Other questions? Is this okay, Priscilla?
Yeah. I didn't hear when you were explaining what the 500,000 meant again. Like
As time goes by, just increase the number of weeks. It's as much as you want. You choose any number. Okay, the next topic is chapter 5. This deals with systems. They can be systems of equations. They can be systems of inequalities. We're going to go over everything. So we are looking at 5.1, 5.4, and 5.5 only. 5.1, 5.4, and 5.5. Okay, in 5.1, 5.1, we're going to look at systems of equations in two variables. Two equations. So what is a system? two conditions of two variables, two equations in two variables. It's two conditions put together with two variables. Well, if we're talking about two variables in two equations, let me copy a problem from page 555. Let's say problem 14 on page 555. So we have 2x plus 5y equals 1, and we have negative x plus 6y equals 8. Two conditions put together. We keep them together all the time by this symbol or any other symbol that you want, but they have to be kept together. There are two conditions, two equations, two variables. If you forget for a moment about the second equation, can you tell me if you were to graph this? How would you graph it? Exactly. It's a line. Excellent. So what can happen here? What could be the solutions? We are talking about two lines, right? Case 1, case 2, and case 3.
So they might intersect.
Yes, if they do, there is a unique solution. Just one. The second possibility is they are parallel. How many solutions in how many points will two parallel lines meet? None. No solutions. And the third possibility is this is one solution. I'm sorry, this is one equation, and here's the other one, which means infinitely many solutions. The systems that have solutions are called consistent. So these two are consistent systems. Consistent. T-E-N-T, sorry. Consistent systems. Of course, this one in the middle is inconsistent system. Okay, so we have two methods that we are going to look at. One method is substitution, and the other one elimination. Is there a third one? Yes. And the fourth one? Yes. And the fifth one? Yes. There are many methods here. Kramer's rule, graphing, matrices, determinants, a lot of methods. But I'm only going to refresh your memory on these two. That's all we have here for now. So we have 2x. I'm copying the system one more time. So in case we're asked to use elimination on this system, I will not eliminate for this. I'm sorry, substitution. I will not solve the equation for x because this is not 1. I will not solve the equation for y because the coefficient is not 1. I will not solve it for this y because the coefficient is 6, but I will solve the equation for x because the coefficient is either 1 or negative 1. So from here I will write negative x equals negative 6y plus 8, and of course I will multiply both sides by negative 1 and get this. What do I do next when I use substitution? Yes, I plug in the first equation. So I will replace x right here by 6y minus 8. And now what did I do? I created an equation with only one variable, and that's what I wanted to do. So then 2 parentheses 6y minus 8 plus 5y equals 1. This I know how to solve. It's a linear equation. I will distribute, combine like terms, etc., etc. So then 12y minus 16 plus 5y equals 1. So this is 17y equals 17, so y equals 1. That's not sufficient. I have to plug it back in. So it's 6 minus 8, so x will be negative 2. So the solution is negative 2, positive 1. Do I trust this? No. I will go back to the original problem, plug it all in, and see if I get a true statement. Actually, two true statements. This is -2 and this is 1, -2 and 1. 2 times -2 is -4 plus 5 is 1 indeed. This is +2 plus 6 is 8 indeed. So I know no one needs to tell me. I know for sure that that is the correct solution. So we use the method of substitution to solve a system of two linear equations in two variables.
So I have a question about you chose the negative x plus 6y. How do you know which one to choose? Does it matter which one we choose? Can we choose either of them and do it?
No, only the variable that has a leading coefficient of 1 or -1. That's what I said. I will not do it for this because it has 2. Not for this because it has 5. Not for this because it has 6. Only for the coefficient when the coefficient is 1 or -1.
And that works only for substitution or elimination as well?
Both, of course. You can substitute for anything you want, even for this and even for that, but you're gonna have to use, yes, you're gonna use a fraction. You're making it more complicated. Would you get the same solution? Of course. But it will just take you half an hour instead of 5 minutes. But yes, you can substitute for anything you want. It's not recommended. Any questions on substitution? Any questions on substitution?
Wait, you plugged in the -2 into the
I went back to the
x is 5y.
to determine the -2, you mean, or to check?
Yeah.
I have to go everywhere. The original problem, everywhere, replace x by -2 and y by 1. Both equations have to be fulfilled. If one of them is not, or both, then -2, 1 is not the correct solution. Does it make sense? Questions? Okay. Can we move on to elimination, or do we need another example with substitution? Say it again.
Another example.
Very good. Please choose, if you'd like, from 5 to 18 on page 555. If not, I will. Okay, 16. In 16, we have 3x minus 4y equals x minus y plus 4. And the second equation is 2x plus 6y equals 5y minus 4. Is this ready for substitution? That's true. It's not. It has to be completely cleaned up. And I have to move x, I have to move y. So I have 2x and minus 3y equals 4. Now the first equation is completely ready. So I subtracted x from both sides and I added y to both sides. Same thing here. So there is no x that I need to move, but there is a term with 5y. So 2x plus y equals -4. Which of these 4 terms will you solve for?
The y at the bottom.
Y at the bottom, very good. So then y equals -2x minus 4. And we are going to replace y in the first equation by -2x minus 4. So the 2x minus 3 in parentheses, -2x minus 4 equals 4. We will distribute combine like terms and get x from here. Stop if you have questions, anything? Okay, 2x plus 6x plus 12 equals 4, or 8x equals -8, so x equals -1. Is this okay so far? So now all I have to do is just replace y. To get y, replace x by -1. -2 times -1 is 2, and 2 minus 4 is -2. It appears, I'm not sure, but it appears that the solution is -1, -2. I don't know. I'll go back. Yes, -1, -1, -1. -2, -2, -2, -2. Back to the original problem. -3 plus 8, it's 5. Negative 1 plus 2 is 1. 1 plus 5 plus 4 is 5. Yes. Negative 2 minus 12. Negative 14. Negative 10 minus 4, negative 14. Now I'm certain I don't need anyone to tell me whether that's the correct solution.
Back up a little bit.
I'm sorry?
You got 14 for that one?
Is that okay? Very good. Other questions? Is this okay? Substitution? Okay, let's look at elimination. I personally prefer elimination at all times because I think substitution is too much work. But not always.
On the exam, if there's any question like this, are you gonna let us choose which one to use, or gonna ask you to
I will let you, most of the time, I will let you decide which one you would like to apply. Very good. So let's take a look at, let's say, let's start with an easier one, like 24. 2x minus 7y equals 2, and 3x plus y equals negative 20. So I'm trying to eliminate one of the variables now. And you can say, well, what did you do here? You did the same thing. You solve for y, you plugged it back in to eliminate y. So isn't this the same thing? Yes, it is the same thing. However, it's slightly different though. Same idea, but the procedure is different. So I'm looking at 2 and 3. If I decide to eliminate x, yes?
Oh, no, I'm sorry.
That's good, that's okay.
It's just that elimination is this when like you multiply something, the whole equation versus a number, and then you want to get them to
Add to another.
Eliminate.
okay.
Correct.
Okay.
Perfect. So if I want to eliminate x, I have 2 and 3. The smallest number that is divisible by these two is 6. So I would have to multiply the top one by 3 and the bottom one by negative 2 in order to eventually eliminate x. I really don't want to go that route because there is an easier route for this problem. Exactly. I'm looking at negative 7 and positive 1. The best thing to do and the easiest thing to do is to multiply the second equation by 7 and then add the equations. Please keep the equations together as I do. 2x minus 7y equals 2. 21x plus 7y equals negative 140. And now we are allowed to add them. And when I add them, indeed, as you see, the terms with y go away. Why? Because we chose that number to be 7, so that negative 7y plus 7y is 0. So then the left-hand side is 23x, and the right-hand side is negative 138. So we divide both sides by 23, so we get x, is it?
6, yeah. Negative 6.
Very good. So now what I have to do next is, of course, go back to any of the equations. Let's say I go back to the first one, and I replace x by negative 6. So then I get negative 12 minus 7y equals 2. Or negative 7y equals 14. Or y equals negative 2. The solution appears to be,
Negative 6, negative 2.
I don't trust it.
And we have to check it with the box.
I could have made an error very easily. So I go back to the original problem. Negative 6, negative 2, negative 6, negative 2. Negative 12 plus 14, yes, it is true. Negative 18 minus 2 is negative 20, of course. So then I'll say yes. That is the correct answer. I don't need anyone to tell us, right? We don't need anyone to tell us. We just checked. Now, the next level, like for example, 28. Let me know if you have questions. Let's stop for a moment and before we continue. Any questions? So, see, in 28, I have 2x plus 3y equals negative 16 and 5x minus 10y equals 30. There is no way by by simply multiplying one of the two equations to eliminate a variable. There is no way. I have to multiply both equations. So now I look at 2 and 5. If I decide to eliminate x, I need to obtain a 10 and a negative 10. So one option would be, let's say a 5 here and a negative 2 here, to get the positive 10 and the negative 10. The second option is to eliminate y. But then it will be in a way easier because I will not have to multiply by a negative number. I will multiply the top by 10 and the bottom by 3. In this case, I will get a positive 30 and a negative 30. That will go away. Now you choose. Say you want to eliminate x, then we'll stick with 5 and negative 2. If you like to eliminate y, which I recommend, then we will multiply by 10 and 3. We have to multiply both equations no matter what.
But that's for the recommended.
The recommended, yes. So I will do this. So then I have 20x plus 30y equals negative 160. And then 15x minus 30y equals 90. Both are okay. The reason why I recommend 10 and 3 is because I may make a mistake when I multiply by a negative number. If I can't avoid it, I will. Is it such a big deal? Of course not. So when I add the two equations, these two go away. So then we have 35x equals negative 70. So therefore, x equals negative 2. I have to go back to the original problem with x equals negative 2. So let's go, I'm going to go back here and I'm going to write negative 4 plus 3y equals negative 16. Or 3y will be negative 12 and y equals negative 4. It appears, I don't know for sure, but it appears that the solution is
Negative 2.
correct. Any questions? I'm looking for a word problem because you'll say, okay, wonderful. The technique is great. Fantastic. Where is it applicable? Show me. Okay, so let's take a look. Are you interested in 78? I'm going to read 78 to you. At the North Campus of a small liberal arts college, 10% of the students are women. At the South Campus, 50% of the students are women. The campuses are merged into one East Campus. If 40% of the 1,200 students at the East Campus are women, how many students did each of the blah, blah, blah? Another one, 80 on page 559. A new restaurant is to contain 2-seat tables and 4-seat tables. Fire codes limit the restaurant's maximum occupancy to 56 customers. If the owners have hired enough servers to handle 17 tables of customers, how many of each kind of table should they purchase? Are we interested in female students at the liberal arts college, or how many tables of each kind, 2 or 4 seats should be blah, blah, blah? We have to choose one.
We do the tables.
The tables, let's do the tables. Okay, a new restaurant is to contain 2 seat tables, so that's problem 80 on page 559. So we're going to read the problem. What do you expect to come out?
2 variables.
2 equations, a system with 2 variables, 2 equations that we will use the techniques that we just practiced. Excellent, that's all we need. So we will always need to see applications of what we're doing. Okay, so a new restaurant is to contain 2-seat tables and 4-seat tables. So 2-seat, I'm going to call it X. 4-seat, I'm going to call it Y.
So that already
So it says, fire codes limit the restaurant's maximum occupancy to 56 customers.
Equals 56.
So 56,
2x plus 4.
2x plus 4y. Excellent. Very good. Let's read on. If the owners have hired enough servers to handle 17 tables,
7x.
X plus Y equals 17.
very good.
I said it was.
So the total number of tables, x of the first kind and y of the second kind, x plus y must be 17, and then the number of people cannot exceed 56. Excellent. So now you tell me what you want to do. I know what I want to do.
Elimination.
I would divide both sides by 2, the first one, and multiply the second one by -1. That's what I would like to do. So then I have x plus 2y equals 28, and negative x minus y equals negative 17. So I have y equals 11. So out of the total of 17 tables, 11 of them seat 4 people.
So 6 it doesn't have to.
And yes, and x will be 6. I claim that the solution is 6, 11. But you should say, show me. We don't know. I'll go back to the original problem. 6 and 11, 6 and 11. Well, 6 plus 11 is definitely 17. But this is 12, and this is plus 44. Is this 56?
Yep.
And I will say yes. So this is a typical situation for a system with 2 equations in 2 variables. Yes.
So I see they divide by example by 2, but if I wanted to, could have just done the multiply the bottom one by 2
By -2.
by -2.
Correct.
And then
Sure.
I would get the same answer.
Absolutely. I already checked the solution. You cannot find another solution. It must be this one that we already found. So no matter which method you use, you may use substitution if you wanted to. It doesn't matter. The answer has to be the same. Now, the system may have infinitely many solutions, which is a different story. But if it has only one solution, I cannot find one that works, and you find another one that works. 2 straight lines cannot meet in 2 points. They either meet in exactly 1 or in all, not in 2. So once we find 6, 11 and it works, no one can find another. Okay, we're moving on to 5.4 and then 5.5. And 5.4, it's the same idea. However, we are not going to look at linear equations only. So 5.4 deals with nonlinear equations, meaning polynomials or anything else. So 5.4, systems of nonlinear equations. Okay. Still in 2 variables. We are still talking about 2 variables. And of course, we're going to talk about substitution and elimination. The same, everything the same. On page 587, let's start with number 8, substitution. 8 on 587. So we have x squared plus y squared equals 5, and 3x minus y equals 5. Again, pretty similar. It's just that now we're going to have potentially more solutions than just one. Now, something like this can meet in more than 1 point, because this is not a line.
So because we have
Can anyone remind us what this is? Forgive me for what type of equation is it? Careful. Think back from chapter 2, the previous test. We've seen something like that. What is it? The equation of a circle. Very good. It is the equation of the circle centered at the origin with a radius of the square root of 5.
Still gonna have more solutions.
So if we have a circle cut by a line, obviously we expect more than one solution. Yes, sorry.
Is it because when we solve for whatever, because the square, we're gonna have like
Plus or minus.
plus or minus,
Correct.
like, most solutions.
Excellent explanation. Yes, this is not a function. Great job. So if we want to solve it, we're not going to do that. But if we want to solve for y, then we have to take the square root after we move x squared to the
What
other
if
side.
we square the bottom equation because you already have.
Then I'm in big trouble.
a negative?
Very good point.
So you
When
can't
I
do that.
square a binomial, how many terms do I get? 3. I will get 9x squared minus 6xy plus y squared, and I'm in big
So
trouble.
you would just move over the 3x and then multiply by -1 on the bottom equation of the y. If you do that,
Say it again.
on the bottom equation, if you move the 3x over
Yes,
and then
I will solve
multiply
for
by-
y, of course, yes. So I will solve this one for y. So this is negative y equals negative 3x plus 5, or y equals 3x minus 5. And of course, I am going to replace y in the first equation and have to square it. Yes, great job. X squared plus 3x minus 5 squared equals 5. And we've been doing or solving these types of equations from day one, really. Okay, so please tell me how we continue.
So you just square 3x minus 5
Very good. So then I have x squared plus
minus
9x squared minus,
30.
yes, 2 times 3 is 6, yes. Very good, 30x, and plus 25 minus 5 equals 0. Very good. So how do we proceed? 10x squared minus 30x plus 20 equals 0. We always try to clean up everything, and this can be cleaned up. How?
Divide by
Very good. Divide by 10, then we have x squared minus 3x minus 2 plus 2 equals 0, and this should not take long.
x minus 1 and x minus 2.
So two options, x equals 1 and x equals 2. But that's not enough. I have to determine the corresponding y values.
Plug it right in.
Exactly, right here. Right here, because I use substitution. When x is 1, how much is y? Perfect. When x is 2. Very good. So this system of nonlinear equations, one is linear but the other one is not, so we have to consider it nonlinear, is 1 comma negative 2. The solutions are 1 comma negative 2 and 2 comma 1. And please go back and check. If you want me to, I will check with you. If not, we'll move on. And you, I'm sorry?
Can we check with you?
Sure. Both or just one?
We can just do one.
Which one? Let's choose.
1, -2.
1, negative 2. Very good. 1, negative 2. 1, negative 2. 3 plus 5 plus 2 is 5. 1 squared is 1. Negative 2 squared is 4. 1 plus 4 is 5. So I will say yes. In the same way, please check 2 comma 1. Any questions? Any questions? Okay, so let's move on to the elimination, or also called addition method. Let's say 20. We have 4x squared minus y squared equals 4. And we have 4x squared plus y squared equals 4. In this particular situation, I don't really have to do much. Why? Oh, simply because I can immediately eliminate this second term. One is negative y squared, the other one is positive y squared. So the left-hand side is 8x squared, and the right-hand side is 8. No problem, x squared equals 1 after I divide both sides by 8. And we know how to solve this equation. It's quadratic, and we know 4 different methods. Very good. This is typical for taking square roots. That's good, but it's not good enough. I have to find y. Yes, I will plug in back in x squared equals 1. Anywhere you want, it doesn't matter. So let's say we go to the second equation. So I have 4 plus y squared equals 4. Oh, nice. So y squared equals 0. So there are, how many solutions does this equation? 2. Very good. Multiplicity 2. It would be a term there, right? If we were to graph. Okay, so then what are the ordered pairs, solutions to this system? 1 comma 0. Excellent. 1 comma 0 and negative 1 comma 0. So this is the method of substitution.
That's quickly.
Same idea. It's just that these ones are not linear. They also have nonlinear situations. I would like to look at a word problem unless you say, no, not yet. I still want to practice this. I want to see more. And we can choose more. Either substitution or elimination or both.
Like types of this.
Nonlinear. Nonlinear. Either
Can we do something, just because this one was really easy.
very good. So you want the substitution or elimination? First method or second method?
Doesn't it really matter? We can do
Okay, you want elimination. Very good. Okay. What about, yes, 40 on 588. X minus 1 squared plus y plus 1 squared equals 5. Can anyone tell us what the equation is this? What does it represent?
That's not slow, is it?
Say it again. It's a circle centered at 1 comma negative 1 with a radius the square root of 5. We don't have to graph. I'm just saying, just to refresh your memory. Good. So can I eliminate? Absolutely not. I don't have the same variables. There's no way. Here we had the exact same variables, x squared, and y squared, but here I don't. So there is no discussion about elimination. So what is the route?
You can solve for y.
I have to solve for y, the second equation. So then y equals 2x minus 3. And I will have to replace it in the first one. This is my only chance, my only hope. Any questions so far before we attack this problem? Any questions? It's a lot of writing here in this one. So we have x minus 1 squared. Can anyone give us the expanded form of x minus 1 squared?
Isn't it x squared plus minus
minus -1.
Very good, minus 2x
1 squared?
That's 1.
plus 1. Remember we talked about this on the first day of classes.
Yeah.
Good. Plus. So I replace now y by 2x minus 3 plus 1. So that will be 2x minus 2 squared equals 5. 2x minus 3 plus 1 is 2x minus 2. So now x squared minus 2x plus 1 plus. The reason why I always start with that is because it pops up almost every class. Plus what? Can anyone square 2x minus 2 for us? First,
4x squared.
minus
Is it 4?
2 times 2 times 2. 8x
And that's 1.
plus 4 minus 5 equals 0. So let's combine like terms now. What do we get? As you see, this is indeed more extensive.
5x squared
But I agree.
minus 10x.
I agree. Lucky me. Of course, I will divide by 5. So I get x squared minus 2x equals 0, and I factor, and I get two options.
0 and 2.
Indeed. That's good, but it's not good enough.
You have to have the ones.
right? I have to find the y values, but not a big deal. Negative 3 indeed, 0 minus 3, and 4 minus 3, 1. So the solutions appear to be 0, comma, negative 3, and 2, comma, 1. I would like us to look at the word problem. See when we use this technique in nonlinear systems.